All right, so today we're going to revisit geometric sequences, and then we're going to add on geometric series and sums. Okay. Learning target, we got new vocabulary again today, geometric means, which just means missing terms of a geometric sequence again today. Then finding the sum given a variety of things, applications, and then the sum of an infinite series. Oh, sigma notation, yeah, okay. We already are good with that one. All right. A sequence in which the terms have a common ratio. What's happening? There we go. Is what we defined as geometric last week. So 1/4, 1/2, 1, 2, 4. How'd I do? Is that geometric with a ratio of 2? Did I do okay? All right. Anybody remember how to write that in explicit or recursive form? We didn't, in my other two classes, I reviewed recursive a little better than this class, I think, yesterday. Anybody remember? I can flip to another slide and it might help us. What's this one? This is explicit. It's based on the term number. So what did my term start with? 1/4? And then I was doubling it n minus 1 times. So to find the 6th term, I would double this 5 times. Does this sound familiar now? Okay. Can you write that as a recursive though? Anyone remember how that goes? You have to list the first term, which was 1/4. Anyone? A sub n minus 1 times whatever the ratio is, right? You just to me, this one is more like in words almost. Starting with this, you take the last term and multiply by 2. It's just the notation for the description of the sequence. Is that working? All right. There is a reminder over here that a sequence, just because a sequence isn't arithmetic does not necessarily mean that it's geometric, right? Sequence can be neither one. All right. Find the 7th term. We'll get back to this geometric means later. This is the formula we're using, and it's on the gray sheet. Okay. Find the 7th term of this sequence. What do we have to find first? What R is? What is R? Geometric means we're doing what? Multiplying by something. Have a common ratio. So if you did negative 24 divided by 8 or 72 divided by negative 24, either way you get what? Negative 3. Okay. If you subtracted here and you said this went down 32, you would have to go down 32 again, right? And that wouldn't work. All right, so this is geometric where R is negative 3. How do I find the 7th term then? Okay, which would look like? Good job. 7th term means we're going to do this 6 times. Okay. Again, the parentheses are important because 6 negatives are going to make a positive. Yes. I'm thinking it's going to be a pretty good size number, right? Well, if I could type, it would be 5832, anybody? Everybody? Anybody not getting that? We're good? All right. Now we're going to revisit that vocabulary of geometric means. Arithmetic means, remember, we're just missing terms. however many there are, missing where they had added so many differences. Geometric means they've multiplied by something and there's two missing terms. So two geometric means two missing terms where they've been multiplying. Remember, the trick is from here to here was multiplied by r once, twice, 3 times. So this would be 480 times r 3 times became negative 7.5. Now, is it possible to have a negative? Can you cube root that? Yes, no? Yes, you can take the odd root of a negative. You can't take the even root of a negative, but you can take the odd root. What's the easiest way for most of us to do that? Type this to the 1/3 power. So if I do negative 7.5 divided by 480 to the 1/3 power, and I do a math enter, I get negative 1/4. So then if I go back and multiply 480 by negative 0.25, I get negative 120 goes in here. And then positive 30, and then negative 7.5, I think. Yes? Negative 7.5. Did I just say positive? Anyway, we good? Turns out good. Self-checking again. All right, so what are we going to try here? How many R's? 1, 2, 3 again, right? So 6 times R 3 times became 162. So does that divide nicely? 162 divided by 6 is 27. Oh, that's even one we can do in our head. What's the cubed root of 27? 3. So what are we multiplying by here? 6 times 3 is 18 times 3, 54 maybe? How did I do? Times 3 would be 150 and 12, 162. That seems good. All right. Any questions? So the important difference between what we did yesterday and today is to remember that you're multiplying. All right, determine the common ratio and find the next 3 terms. I just put this question in here because you have to remember they don't have to just be numbers. They could be algebraic expressions. What are they doing every time, guys? Multiplying by 2. And the next 3 terms would be 8x plus 8, 16x plus 16, and 32x plus 32. Okay? Any questions? Find the first term of this sequence, okay? So there was, if you like formulas, you could do this. The 6th term is the first term times the ratio 6 minus 1 times. What are we going to plug in here? Point 1 is the first term times the ratio 5 times. So can you work backwards? We just divide both sides by 0.2 to the 5th. Get the first term is, so 0.1 divided by 0.2 to the 5th. I got 312.5. Anyone else? Okay, so I could say, okay, if that's the first term, let me check. I'm going to multiply by 0.2 once, twice, 3 times, 4 times, 5 times, 6 times, and I'm down to 0.02. Did I do something wrong? Oh, it was supposed to be 0.1. Yeah, I'm good. Yeah, 5 times was 0.1. Sorry, I went too far. We good? Find R. Now what? Anybody describe this to me? If I wanted the 10th term, I took the first term times r how many times? 9 times. So this term is 7680. This term is 15. And I have r to the 9th. Well, that sounds fun. 7680 divided by 15 is 512. How are we going to get rid of r to the 9th? Yes, what are we going to do in our calculator? Yeah, I would do to the 1/9. There is a way on your calculator to do the 9th root. Yeah, you have to do the number first, I think. So you would do, I want the 9th root. For the newer ones, yeah. See, mine just puts it up there when I do that. And then 512. I would prefer to just type 512 to the 1/9 because I'd like you to get used to that idea. But the answer is 2. Is that all they asked for, guys, was what is the ratio? Yes? Okay. So number 4, I think I printed this without fixing it again, or did I fix it on yours? Should not use the word geometric and arithmetic in the same sentence. Write a geometric sequence that has 3 means between 7 and 567, but they're geometric means, not arithmetic. Okay. So this time we have 3 missing terms. So how many times did we multiply by r? 1, 2, 3, 4 times. So if we divide by 7, get 81, anybody? And the 4th root of 81, somebody knows that one. Square root twice, right? Would be 3. Okay, so what are the missing terms then? Gotta take this and go back here. 21, 63, and 189. And then this checks the 567. Okay. Any questions? All right, now the new stuff. There are 2 formulas you can use, but I've only given you this one on the gray sheet, okay? To find the sum of a finite geometric series, meaning something that they are multiplying, but they're going to add them all up. So we're taking times 2, times 2, times 2, times 2. Okay, and finite means maybe I want you to end when I get to 16 or whatever. Okay. The problem with this particular sequence for most students, it says to find the sum, you take the first term times. You don't have to know the last term, so that's nice. Okay, but it's 1 minus r to the n, all divided by 1 minus, and you really don't need that parenthesis inside here. Okay, but here you do, because if you put a negative number in and raise it to the power, it can't cancel the negative. So some of you are going to try to skip steps there. Everybody good on where you're going to put extra parentheses? This is for an infinite geometric series. It says you can find the sum, let me give you an example, for whenever r is less than 1. So if I had 100, 50, 25, 12.5, so it's getting half every time, right? Eventually that's you can approximate what that's going to add up to. Does that make any sense to anybody? If you added those up, what you keep adding on is getting smaller and smaller and smaller and smaller. So you can estimate what it would add up to in the end, because eventually you're basically adding nothing. Does that make sense? And the way you do that is you take the first term divided by 1 minus r. So let's just do this one, and then we'll go back and talk about this kind. But this works when it's infinite, when they have the dot, 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 okay? We can find the sum of all of these is going to be approximately the first term divided by 1 minus, what were we multiplying by? Nope, we were multiplying by 1/2, right? So we would get 100 divided by 1/2, which would be, anybody? 200. So if you added up those first three, where are you at, guys? 100 plus 50 plus 25 is 175, plus 12.5 would be 187.5, plus 6 1/4, 193.75, plus half of that. But do you see where what you're adding on gets really tiny really fast, right? Eventually. So it's going to approximately add up to 200. All right. You have this in your notes. And I would make sure on my notes I said I've got to remember that I'm going to need an extra parenthesis there. All right. It says find the sum of the first 12 terms of this series. So here's our first term. What is the ratio? Well, we should be able to do any term divided by the previous. Anybody getting R is 1.25? You could try 9.375 divided by 7.5 to make sure it's working. All right, if we know the first term is 6 and R is 1.25, to find the sum of 12 terms, what does that mean? What's 12 in our formula? This would be the n. No. If you were writing the sequence, yes, you would say 6 times 1.25 to the n minus 1, okay? But when you do the sum, guys, what's the formula? Let me take a little picture of it here for you. Well, that's not a good screen. And I wrote all over this one, but it's this formula right here. Does it have an n minus 1? No. Okay. So don't get confused. The formula, and it's on your gray sheet, does not have n minus 1. It has n. All right. So back to plugging things in. The first term is 6 times a giant parenthesis. Then on the top, you don't actually need a giant parenthesis. You can put one around the top and one around the bottom. So I'm going to do 1 minus, what's R? 1.25 to the 12th divided by 1 minus 1.25. And because this is a positive number, do you really need those extra parentheses in here? No, but be very careful. All right, 6 parenthesis 1 minus 1.25 to the 12th divided by 1 minus 1.25. Okay, please make sure you're getting this to work. Anybody get an answer? How do we know if that's exact? Not so much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes out 10 places, so it's probably not exact. I'm not sure we could make that exact. 6, 1 minus 1. Yours changed it to a fraction? Oh, yeah, mine's not going anywhere near a fraction. Yeah, it won't even do it a fraction. The only other thing I could try is what if I put it in as a fraction? 1 minus 5/4 would be the fraction. Then I would need parentheses. To the power of 12. I'm trying to do just the top even. Yeah, no, I'm not getting anywhere. Okay. So that one I would accept like that. I think I made them so that they came out nicer on the quiz, but if possible, find the sum of the geometric series. Why is this not using the same formula? Anybody know the difference between this question and this question? Nope, that doesn't matter. This wants a partial sum, guys. The sum of 12 terms, right? This doesn't say the sum of a particular number. It said the sum of the whole series, okay? When it says the sum of the whole series, then R has to be less than 1 or you can't find it. Does that make sense? If it's growing, are you ever going to be able to add up all the terms? No. But if it's getting smaller and smaller and smaller, then we can approximate all of the terms. If we do 8 divided by 40 here, we get 0.2. So it is less than 1. The R is less than 1. And then the formula is just take the first term divided by 1 minus the R. Is it 50 maybe? I have no idea. 40 divided by, yes. Okay. The first 3 terms almost add up to 50, right? But what's happening if we keep going? No, smaller than that, right? 1.6 times 0.2. The next term is only 0.32. And the next term after that is 0.064. So do you see we're almost adding nothing already? We're adding 0.0 something. All right. Find the sum of the first 7. So which formula are we using here? This, finite, good. Sum of 7 terms, where the first term is -1, and R is +4. Okay, any term divided by the previous term. Okay, then the formula goes what? Take the first term times 1 minus R to the n, which is 7, divided by 1 minus R. I got -5461. Anybody? Please make sure you're getting that, though, because like I said, this is the formula. I'll get people write it correctly on the quiz paper and then totally get the wrong answer when they type it in their calculator. Any questions? All right, find the sum of the geometric series if. Okay, what's wrong? Okay, how are we going to figure out if this was an arithmetic sequence? We'd be in good shape because you need the first and last term, right? Well, you'd still need the number of terms it is, so I guess we wouldn't be in that good shape. We don't need the last term, but we need to know how many terms we're adding up to get there. Because they want us to only add up to here. Yeah, good question. R is less than 1, so we could say what's the sum of the whole series, but they want us to stop at this term, which is kind of weird, I agree. So they took 8. Let's go back to the original form. They took 8 and they multiplied by what? 1/4 n minus 1 times. And when they were done, they got to 0.03125. So how can we back out of that to find n? Divide by 8. That sounds like a good start. I didn't put one like this on the quiz, those of you who are panicking. So I now have 1/4 to the n minus 1 equals 0.03125 divided by 8. Math, enter, enter, is 1/256. Okay, now, I love this question. Anybody know what we need to do? We can't multiply by 4 because of the exponent. It is a log question. Okay. If we rewrite this, we'd have the log of 1/4. We could move this out in front, right? Equals the log of 1/256. So, log of 1 divided by 256, now divided by the log of 1/4. Anybody get 4? So we get n minus 1 equals 4. What we did there was divide both sides by log of 1/4. So we do get n equals 5. So it was the sum of the first 5 terms. We're still not done, I don't think, are we? Okay. Did I already mention that I didn't put this on the quiz? Okay. I promise I didn't put this on the quiz. All right, let's find the sum of the first 5 terms and finish this question up. How does the formula go? 8 times 1 minus 1/4 to the 5th, and we don't do minus 1, all over 1 minus 1/4. Like, okay. Hope you can type better than me because I'm struggling. $10.65625, which is exact, or 65625, or 341/32. Did someone else's work out that way? Okay. I'm just curious how close this is. If you use the other formula. See, Ariana's making me curious. It would be the first term divided by the quantity 1 minus 1/4, and it would be 10 2/3, or 10.66, so pretty close. All right? Not at the quiz. Where did I lose you? Is that not what I wrote? That's okay. No, I was talking about if you said it's just an infinite series, okay, the sum to infinity would be the first term over 1 minus the ratio. And when you did it that way, you get 10.666. So it's really close. The fact that we only added up the first 5 terms is really close to the infinite series. That's what I was talking about. Yep, we're good. All right. Yay! Question we can just do on our calculator. I'm going to pretend I don't have that nice calculator because I want to practice where all these buttons are. The sum of the sequence. Second stat, arrow to the right twice. 5 parenthesis 1.06 close parenthesis to the n minus 1. Uh-oh, need extra parenthesis around that, I think. Because mine didn't go up into an exponent, so n comma 1 comma 11. All right, did someone else get this disgusting number? Okay. And I'm guessing that it doesn't go to a fraction. Oh, mine did. Did yours go to a fraction? I don't know why mine did, because I did it differently, but yeah, that's just disgusting. Okay, the decimal would be fine. Are you not getting it? 1 through 11? You can leave it blank. It's just 1 or blank. If you do math enter, since you did it that way, will yours do it now? No? Okay. I don't know why mine did, because it surprised me. Usually the older ones don't. Okay, find the sum of the first 16 terms. Okay, what form is this written in? Recursive, okay? So in order to do the sum of 16 terms, we need the first term and r, right? We need to do this, okay? Could I write a little bigger and messier? The first term is 1. And what is r? -2. This is the one where everybody messes up, because what does everybody do? Yeah, but they also want to do this. Can you do this? Why can't I do that down there? Can I do that down there? 1 minus a -2 is going to be 3, right? But can I do it up here? Because of the exponent, it's going to become positive all by itself, right? And it's not going to cancel that. So it doesn't matter if you do this down here, but you can't do it up top, and that's what messes people up. So it's better off to just put a lot of extra parentheses and get it right. 1 minus parenthesis -2 to the 16th all over 1 minus -2. I got -2145. Good thing math teachers don't have to be able to read numbers. Anybody? Yes? Anybody not getting that? Y'all are putting your extra parentheses in correctly? Did you say you didn't or you did? You didn't get it? Yeah. I warned you. Try again, okay? All right. These are supposed to be infinite. So the question is, what's r? R is 3/8. What's r on this one? 1/2. What's r on this one? R is 3. They're going to multiply by 3 again and again. So if you weren't sure, guys, if you put in a 1, you would get out 13 on this one. And then when you put in a 2, you'd get out 39/8. So they multiplied by 3/8. Okay? On this one, obviously the terms are listed and they're multiplying by 1/4. If you put in a 1 on this one, you'd get 3 to the 0 power, which is 1. If you put in a 2, you get 3 to the 1 power. Put in a 3, you get 3 squared. All right, one of those we can't do. Which one of these is not like the others? Which one can't we do? Yes, you can't find the sum of an infinite sequence if the sequence is growing, right? It's going to approach infinity. It's not going to find a sum. What's the formula for these other two? The sum to infinity is a sub 1 over 1 minus r. All right, so what was the first term in number 19? 13 over 1 minus 3/8, or 13 divided by 5/8. I got 0.325, anybody? Or 13/40th? Nope. 13 divided by... No, I did not. Just kidding. I typed it in wrong. That confused me. 104 over 5? 20.8? Okay. And this one here would be the first term is 10 over 1 minus 1/2. I think I can do that one. 20? Everybody good? Honestly, infinite sequences aren't on the quiz. I kind of forgot to put them on there. All right, number 12, accounting. Each year, there is an application question, and it's one that messes everybody up, so please be paying attention. Each year, the value of a car depreciates by 18%. We've done these questions last semester, right? 1 minus 0.18 would be 0.82 we're going to multiply. You bought the car for $22,000 in 2009. Okay, how many years? 2009. That's where everybody messes up, okay? Because we've been doing n minus 1, right? Everybody wants to put to the power of n minus 1. The issue is, if this was term 1, so you took off 2008, you'd take off 2008 here, and this would become... If you call this, you guys want to call this term 1, right? Yeah. Okay, so you'd have to take off this so that it would be a 1. If you took that off here, you'd get a 7. So then if you do 7 minus 1, which is 6, I'm not suggesting you do that. I'm suggesting you just do it like we did last semester. Last semester, all we did was subtracted those two numbers and put a 6 up there. Just don't overcomplicate it because we're in a new semester. Okay, 22,000 times 0.82 to the 6th, 66.88 and 15 cents, or roughly $6,688. If you need to, count it out on your hands, okay? 2009 to 2010 is the first one, right? 11, 12, 13, 14, 15, 6 times, okay? All right, population is growing by 23 points. What are we multiplying by then? Right, 1.235 is 123.5% growth. The population in this year was this. So that's, we could call it year 0 or year 1. It doesn't really matter. Just know that we're going to multiply to the power of what? Yeah, 30. That's going to be a really ginormous number. That was using it to predict, yes. So if it continued to grow at that rate beyond there, what would happen? Yeah, I was kind of confused too. All right, I don't know if I can type this in right. Okay, 898-773-2246. Anyone? No? I might have typed something wrong. Okay. You're doing it over again. But see, all right. Let's finish strong here, guys. An employee agreed to work on a salary where his annual salary increased 4.5% each year. He earned this for his 10th year. What was his first year? Oh, good. So the first year times 1.045, how many times gave him his 10th year? 9 times. Because he only got 9 raises, guys, right? Because he didn't get the 10th term. So we're looking for the first term. Yes? Oh, yes, it is. But this was in 10 years. I think he's right. I think in this 10 years, it grew this much, not every year. So, yes, I was. Okay. We all know Fati's smarter than me. Yes. 3010552, which is 30 million? Okay. All right. That's not on the quiz that way, okay? Because this said for 10 years. In this 10-year span. So it's like so how many decades? Every decade it's increasing by yeah, I did not put it that way on the quiz. Okay, let's finish this question, guys. We're supposed to be 50, 81, 41. So we're going to divide 50, 81, 41 divided by quantity 1.045 to the 9th. I got $33,700. Yeah. So his first 10 years, the sum would be, so the 10th, yes. I did not get that. I got 414,000. The starting, you didn't do a starting one? Yep. Okay. Is that the last question? Yay! So we managed to finish. Okay. And this bookwork is on the assignment sheet. Yeah, have a good day, guys. All right, tomorrow we will review. Shoot! Anybody want the review for the quiz?